Hey everyone, in this video we're going to be starting our how to solve our systems of equations. This video is specifically going to be by graphing. There are lots of other ways to solve systems of equations, so if you're interested in seeing those methods, please subscribe to our channel and check those out. So by graphing, I'm going to show you how to use your graphing calculator to do this at the very end as well. All right, here are your steps. Pretty straightforward. The first thing you have to do is graph your first equation, and then you graph the second equation, and your answer will actually be where they intersect. And we'll also talk about what happens if they don't intersect. So here we go. All right, so I'm going to graph my first one. Now my graph's a little fuzzy. This is the best one I could find. So I'm going to graph my first equation, right? And if you don't remember how to graph, remember we start with the y-intercept. So we start with b. That's our y-intercept, -9. So let's see. A little fuzzy here. So there's my -9. Then my slope is 3, there's m. So my m is going to be 3, so that means 3 over 1. So I'm going to go up 3, 1, 2, 3 over 1. I'm going to do this a few times, up 1, 2, 3 over 1, 1, 2, 3 over 1. That way I can kind of get a straight enough line. I know that while I'm graphing here, I'm going to go up one more time. 1, 2, 3 over 1. When I graph digitally, it's not as good as if I have a ruler. So you might want to get a ruler for this section. Whew. There we go. All right, and I'm going to show you again how to do this on the calculator. That way it can be exact. I'm going to graph the second one, same thing. Start with -4. If you want to use a different color, go for it. Let's see. Let me do that real quick. Here we go. Pointer options. Let's change our color, shall we? Let's go blue. All right, so here's our 4. And then now my slope is 1/2. So we're going to go up 1 over 2. Well, that was convenient. Up 1 over 2. It was very convenient. Because what I'm looking for is where these two graphs intersect. That's what I want to find. And they intersect right there. Okay, so I know it's kind of fuzzy, but on my side, that's going to be 2, -3, and that's going to be my answer, is actually that coordinate point. If you wanted to check it, what you can do is plug it in, because you know that means x equals 2, and then y equals -3. So you can plug these values in. So if you wanted to do 3, or I'm sorry, start with the y, -3 equals 3 times 2 minus 9. Well, you're going to get -3. That works. Same thing here. -3 equals 1/2 times 2 minus 4, and you'd still get -3. So you're welcome to work those out in your own time. But that's how we do it. So you just graph your two lines, and where they intersect is your answer. All right, you try these two. I'm going to give you a minute. Go ahead and pause it. I'm going to go ahead and start these. First one, let's see. I'm going to start at +4. Then I'm going to go down 3. 1, 2, 3 over 1. Do this a few times. 1, 2, 3 over 1. 1, 2, 3 over 1. Make sure I don't need to go anymore. Yeah, that's good. All right, and connect your dots as best you can. All right, I'm going to keep it blue this time to graph my second one, because you don't have to change colors. That's just a choice. You get -2 to start, and then go up 1, 2, 3 over 1. Well, that's good. And then again over 1, up 1, 2, 3. Just looking for where they intersect. Now, if it looks like they intersect off the graph, you may need to have a bigger graph. So right there, that's my answer, and that is the point 1, 1. So I hope that's what you got. You're welcome to plug it in and check. Whoop. Or when you learn the graphing calculator method, if you're allowed to use a calculator to check, then I would encourage you to do that. All right, so that's our first one. I'm going to erase the graph, because I'm going to use the same graph for the second one. Now the second one you have to rearrange first. So I have x minus y equals 3. I need to rearrange that. So I'm going to go ahead and do this up here. So I have -y equals -x plus 3, right? Divide everything by a -1. That just changes your signs. So y equals +x minus 3. So that's this first one, rewritten in a slope-intercept form. And do the same thing for the bottom one. I'm going to do it a little different this way. This one, I'm going to switch the y and the 3. So this is going to become 7x plus 3, because it's a -3, so it becomes a +3 on the other side. And that's going to equal a positive. So let's see. I'm going to start with my first one. So I'm at -3. I'm going to go up 1 over 1. Up 1 over 1 because that's my slope is just 1, so it just goes up by this diagonal here. And then for your second graph, we're going to start at 3. And we're going to go up, and actually here, I'm going to go down 7 and backwards 1. So 3, 1, 2, 3, 4, 5, 6, 7, and backwards 1, which is right there. Because I know this one is really, really steep because that slope is the 7. Ooh, and that second half is not drawn to the best ability. All right, so your point right there is going to be -1, 4, and that's your answer for the second one. So -1, 4. So drawing by hand is going to give you be as accurate as you can be. Use a ruler or a straight edge. That would definitely help when you're drawing. Hard to do on a computer. All right, so there's those two. I'm going to show you some exceptions. So right here, you're welcome to pause it and try it, see what happens, but I'm going to go ahead and just show you. For the first one, just graphing real fast, -3, up 2 over 1, up 2 over 1. All right, there's my first graph. Yikes, let's redo that. Okay, there's my first graph, which is slightly better. Slightly is a generous word. And then my second graph is up here at 5, up 2 over 1, up 2 over 1, etc. All right. All right, and then down 2, backwards 1 if you want to do that. Okay, so notice with these two, you end up with parallel lines. Parallel lines, okay? And that shouldn't be surprising because look, these slopes right here, those 2's, are the same and their intercepts are different. So these are never going to cross. They're just going to go in space forever. So that means my system of equations here, it has no solutions. Remember, that's an empty set, so that's going to be no solution. So that's because my slopes are the same. They can't intersect. It's impossible. They're never going to. Okay? So that's one of your exceptions. Try the second one now if you haven't already. And I'll put that up here. So this one's kind of rewritten. The first one, let's see, we're going to start with 5, and then I'll rewrite the second one. I'm going to go down 1 over 1, sorry, negative slope. All right, give this video a thumbs up if you've learned something, or if you like the color blue. And for the second equation here, I'm going to divide everything by 2 to get the y by itself. I've got y equals -x plus 5. Pause. What do you notice? What is that? What is that equation? What did we just do? I just graphed that. Look at that. That's the same thing. It's the exact same thing, which means that the solution to this system of equations is going to be any point on the line. So for here, your answer is going to be, you can say infinite solutions. Infinite sol. Infsol. Hard to say. So you can say it's infinite solutions because it's going to be any point on that line. Specifically on that line, not just some random point like, it can't be that point because it's not on the line. It's got to be something that's on my line. Something on this line right here. But anything on that line will work because it's one line. I don't have anything to solve. I don't have an intersection point. Crazy. All right. Last thing I'm going to show you is how to do this on a calculator. So I have the instructions here you're welcome to take a picture of. I'm going to go ahead and just show you. I'm going to show you how to put this on your TI-84. You could have an 83. It will work the same way. I actually have a digital version. This is just the free trial. You get like 90 days free trial of the calculator if you don't physically have one. And then they have a computer version. But if you have the physical calculator, this is the same thing. This is, again, the TI-84. This one's the newer one. This is the Plus CE. The older version works fine. That's what I use in my classroom. So whichever one you have. Down here, clear all this for you. This is going to show you the buttons on the bottom that I'm pushing. So here's y equals, and I'm going to just type this equation in. So 3x minus 9. Okay, then I'm going to go down to y2. And then that 1/2, you can either do in parentheses 1/2, or I'm just going to do 0.5. So 0.5 and x. Okay, now the xt theta n, that's where all your variables are. Minus 4. And right here, notice you have the black boxes around your equal sign. That means it's going to graph both of them. If you have an older calculator, it's the same thing. It's highlighted. You're not going to have all these colors, and that's fine. So we're going to go ahead and graph it. Ooh, cool. So it's going to graph it. I want to find out where we intersect here. Now, before you go, oh, well, it looks about, your calculator can give you the exact answer. So let's actually use that. It's really useful, especially if you have a decimal. This will show you. So I'm going to go to second, trace, and look what number 5 is. Intersect. That's convenient. All right, so it's going to ask me Y1, and it's going to color coordinate, I believe, at the top. So first curve, I don't have any curves here. When we get into quadratics, you'll see that. So I'm just going to hit enter. That means, yes, this is my first line that I'm looking at. And then look, my second line, Y2, the red one. So because it says I'm doing the blue one and the red one, it's going to find where those lines intersect. If you had a third line, you could go through and say, no, I want the blue one and the green one, or whatever it is. We will do that in a future video that's coming. So I'm going to hit enter for yes, and then it says guess. So then you still need to hit enter one more time. So it's saying, okay, you got the first line, you got the second line. Are you sure? Yes, I am sure. So let's go ahead and hit enter again. And then look here, the intersection, it tells me it's 2, -3 right there, which is what it looks like it should be. So those are nice and exact. If they weren't exact and had decimals, that would show you like 0.5 or whatever it may be. Okay, and that's how you do this on a calculator. I'm going to pull back to slides. That's just what these instructions say here. You're welcome to use that as a reference if you need it. Last slide. Let's go back to our slides here. All right, when should you use graphing to solve a system? So you have lots of different ways. I mean, I can think of 6 off the top of my head methods how you can solve a system of equations. Some are more straightforward than others. This is just graphing. I think you should use graphing for your systems of equations if you happen to have a graphing calculator and it's already in slope-intercept form. If you have to do a lot of movement with the equation to get it in slope-intercept form, there will be other methods that we'll have videos on that you can use that. It'd be much easier. So graphing is not my preferred method, especially if you have to graph by hand, because you saw my graphs. Yikes. Especially if it's a decimal, it's gonna be like, that's a pain. That's really hard to graph. So that's what I have for you for this video. This is graphing with systems of equations. I hope you learned something. Again, subscribe to our channel. Please like this video. It really helps us out. And I look forward to teaching you something new soon. All right, guys, have a great day. Bye.